Hello, this is a review on some function notation and composite functions as well. And I'm going to go through a couple examples. So first of all, you may get a problem where it says something like simplify, and then I found some problems that I think are going to be helpful in the future. And it's going to say you're given this function f of x plus h minus f of x over h. And this looks really funny, but I promise you this is going to look less funny in a couple weeks. But it's going to say simplify this expression when f of x is equal to, I'm just going to say x squared. This is going to change. Whatever this f of x is here, that's going to change. So how you do this is, first of all, I want you to identify f of x plus h. On some practice problems, I might have put like x plus a, but in this case, it's f of x plus h. What that means is instead of x, you're going to write x and h. So f of x plus h. You're going to take the original function here. You see how it says x? Well, I'm going to replace that with parentheses. Now, instead of entering x here, I'm going to enter x plus h. You've done this before with numbers, actual numbers like 2 and 4, but you haven't done this really as much with letters. So every time it says x, and they want you to plug in f of x plus h, instead of x, you write x plus h, or whatever's in these parentheses. There, that's almost it. So let's go back to evaluating this function here. Let's go back. So f of x plus h is this expression here. So this is going to be equal to x plus h squared. Because instead of x squared, it's f of x plus h minus, take away the function. What was our function again? It was x squared. So instead of f of x, I wrote x squared. Instead of this business, I wrote this business squared. Remember, our function that we're dealing with is something squared. Over h. H doesn't change. H in this case is like, I don't know, a constant or something. I do know, it's constant. Okay, continue to simplify this. X plus h is, this is going to be a square, and what would be really helpful for me is if you just memorized a plus b quantity squared as a squared plus 2ab plus b squared. That way you don't have to do box method or FOIL a million times. Like you should, this is automatic, and you should become more comfortable with it. So it's like the first term squared plus 2 times the product of the two numbers and variables plus h squared minus x squared. That minus x squared, I'm just copying down the rest of my expression. Okay, this x squared and this x squared, delete. And I'm going to continue to simplify this. They actually have a greatest common factor in the numerator, and that greatest common factor is h. And then I have an h in the denominator, which is nice because then I simplify my answer. So this is how to evaluate functions with variables. So if you want to document this, if you want to look up more videos on this, it's how to evaluate functions with variables. Now I want to go into composite functions. Composite functions. Sorry for the noise. I live on a very busy street. Okay. Let's say, I'm just making this up. I'm going to give you a function, call it g of x. Oops. Minus 1. And then I'll give you another function I've named h, and that's going to be 5x minus 7. I just made up these functions. Now, this one you may know this one, h of g of x. So what this means is you evaluate g of x and then you plug in g of x into h of x. So what you could do is take this entire thing, 2x minus 1, and you could write it in here. You could do that. And to do that, it would just end up being this guy was purple, right? 5 purple would be 2x minus y. And then you can simplify it. So this is a composite function. It's a function within a function. You would continue to simplify this, combine like terms. What I want to bring up was h of g of x, which is the same thing. It's the same thing. On the diagnostic, you guys multiplied h of x and g of x. And I was wondering where you guys all got this answer. I think you guys just multiplied. So this is actually, these are equivalent. Same. These are the same thing, h of g of x. So okay. And if I gave you this, like h of g of 3, why not 3? What I like to do is I actually like to evaluate g of 3 first. So instead of x, I replace 3. This becomes 5. And then I evaluate h at 5. Then I take my output of g and it becomes my input of h. Whatever this is. I'm not going to do this. 25 minus 7. Okay, so this is called composite functions. That was a quick review. If you want to look up more on composite functions, those are your keywords.